Hello and welcome to the Dragonfly Daily. I am your host, Mike, the product manager for Dragonfly, and I am here to deliver another daily lesson on using Dragonfly. The topic of today's lesson, lesson 4, working with Multi ROIs. This is about image segmentation. Multi ROIs are what we call multi-regions of interest. You're going to see a lot about that today. We're going to cover both Multi ROIs and ROIs, and this ROI and multi-ROI, this is the pathway to quantitative for quantification. If you're doing quantitative analysis, then Dragonfly is the thing for you, and multi-ROIs are the pathway to that quantitative analysis. If you're watching on YouTube, hit the subscribe button. If you like this topic in particular, be sure and hit the like button. So thank you for your attention. Just as a reminder, this is lesson 4. Previous lessons are available online, streaming through YouTube. So this is the lesson on working with multi-ROIs. Tomorrow we'll hit a lesson on Movie Maker. Be sure and follow along live if you want, or if you're watching on YouTube, you can always watch it the same day or anytime in the future. That's what's great about having these archived and available on YouTube. If you have follow-up questions, you can ask them live at the end of the live webinars, or you can send follow-up questions to the forums. So, lesson 4, working with multi-ROIs, image segmentation. We are using Dragonfly 4.1, so if you have a Dragonfly 4.1, you can install it, or you can follow the webinar in installing it. And we're just using the out-of-the-box experience, so you can do these exact exercises just like I'm doing. Now, the data that I'm using for today's webinar is actually the exact same data that I used for lesson 3. So if you visit, let's search for ORS Dragonfly, and here at ORS Dragonfly, we'll just go to this page. And from this page, we can go to sample datasets. So I just clicked on Learn Sample Datasets. You can grab this graph of small sand pack. It's an ORSObject file that has a graph and some ROIs. That's all you need. That's what we're going to work with today. So here I am in Dragonfly. On lesson 1, I used import image files. On lesson 2, I used import mesh files. And then on lesson 3, I used import ORSObject files with this. You can also get import ORSObject from a file with this. So I'm going to click this button. I'm going to browse to my downloads folder, and I'm going to find that file, which is called graph test case sandpack.orsobject. I'm going to click open. You see that there are a number of objects encoded in this one file. I do not need the graphs that we had yesterday, but I will keep the shapes, the overlays, the regions of interest, and data sets. So we have had lessons on images, which we sometimes call data sets. Today is starting a lesson on ROIs and multi-ROIs. We have not had a lesson on shapes or overlays. We'll get that on the agenda before long. I'm going to go ahead and import these data. As a reminder, this particular data set comes from this hydrate-bearing sand entry on the Digital Rocks portal. You can go and get it yourself. This is not the data set that the hydrate-bearing sand data set. This is a derivative. So I grabbed that data, I cropped it to a very small region and masked it, and that's what we have right here is this small sand pack. And then I have some other derivative data. So feel free to grab the raw data set, and if you do any of this work, please reference Xingyu. I haven't met Xingyu, but please reference Xiangyu's data. All right. Now, the data set that we're looking at is this small sand pack, and it's really small, 100 by 100 by 131 pixels. When we looked at this yesterday, we saw that I had a segmentation called sand grains. I can turn on the visibility here, and a segmentation called pore space. I can turn on the visibility with these little buttons over here. Here's a lesson you have not seen yet before. These are what we will call them filter buttons. And so I can click all and I see everything, or I can click this button and I'll only see data sets, or I can click this button and I'll only see ROIs. If this list gets very long, if you've got a bunch of measurements or a bunch of ROIs, you can filter what you're seeing, or I can see data sets and control click, see data sets and ROIs, or I can see everything or only those things that are visible. So that's what these buttons at the top are for here. There was a question at the beginning of the webinar about zooming in on the window leveling tool. If I go over to main and I find the window leveling tool and expand it, you'll see that this is the histogram for the selected data set. And of course, we can adjust the brightness and contrast, or the window leveling as we discussed in lesson 1. If you want to zoom in here, I can. On an older release of Dragonfly, there was actually a zoom button somewhere down here. Now it's just interactive. I can use the scroll wheel on the mouse to zoom in, and it does resample this histogram, so it gets higher and higher resolution. Once I'm zoomed in, I can, well, let's see. Yeah, it's not inside the window, but if I'm outside the window, I can drag with the left mouse. And this behavior is improved in 2020.1. So we'll try and revisit it when we in a webinar after we've launched 2020.1. So enough of that. We've got content to talk about with respect to ROIs and multi-ROIs. I'm going to double click to dock that back in place. Now, I have right here an ROI called sand grains, but I did promise that I would show you how to create that ROI on your own. I haven't even told you what an ROI is or what the topics for today are. So working with multi-ROIs, we're going to talk about image segmentation. So what is image segmentation? Oh man, another mistake in my slides. Let's get that fixed. So let's fix that. This is what happens when you deliver new content every day, and sometimes you're just not careful enough. So we are not talking about poor network models, but that is an answer to an earlier question. Roots, vasculature in plants, neuronal connections, those are all applications of graphs. But today's lesson is multi-ROIs. Image segmentation is about labeling pixels in your image about what material they are. So if I have a sand pack, for example, which pixels are sand grains and which pixels are air? We're going to use ROIs or regions of interest and multi-ROIs for multi-regions of interest. We will look briefly at computing porosity today, or really any volume fraction. We're also going to do object analysis, which is the tool for doing quantitative analysis on multiple objects. So these could be grains or pores or fibers. We will look at making measurements such as volume, surface area, aspect ratio. We're going to see how you can show or hide selected objects. We're also going to show very easily how you can color code your objects by measurement. We'll show you how you can export these measurements to ROIs or to other ROIs. You'll see what I mean when we get there. We'll also look at exporting measurements to a spreadsheet, to a comma-separated values data structure. And we may touch briefly on measurement inspector, and as always, we'll save our data as ORSObject. That's the roadmap for today. Now let's get back into Dragonfly. So we have an image. If we wish to label these pixels as grain and these pixels as pore, we have tools for doing that. We're going to go over to the segment tab on the left. And over here we have three panels: ROI tools, ROI painter, and segment with classifier. We're just going to use the ROI tools panel for today. Now, we're not going to get very deep into this. We will have lessons, I think, next in lessons, somewhere between lessons 5 and 10, we'll be covering a lot more on segmentation tools. There is a range tool over here. If I click the define range and I actually show the histogram, this is the histogram for this particular data set. If I wanted to select the high intensity pixels, I could drag this slider over, and now I have the high intensity pixels selected. Now I can click the reset button. Instead of doing this interactively, I could just click this button, upper Otsu. This is going to apply the Otsu's algorithm. This is from Otsu in 1978, I think is the literature reference, where it's just an automatic segmentation. So if you have a two-phase, so a peak over here and a peak over here, it tries to find the optimal separation by doing an entropy minimization. Don't have time to talk about it. Check out the paper. Once I have done this interactive thresholding, I could say, let's just add this to a new ROI. If I click add to new, now I have a new ROI over here. I'm going to turn off the define range so it's no longer showing as red, and I'll double click here to rename. These are my sand grains. So I've got sand grains I labeled. That's how I did this. Now we could also do the inverse. So let's say I delete that ROI just by clicking the delete button. Now suppose I take a define range and I reset let's reset here, and I do lower Otsu. Now I have all the dark grains. But you'll notice that I have not just the air space, but I also have the space outside the cylinder. Well, I'll do add to new, and now I have all of my air space. Now, we have not looked at shapes, so I'm turning off define range. We have not looked at shapes, but I have created a cylinder in this workspace. So if I go over to main and I scroll down and I show you my multiple view layout, and I turn on cylinder, I do have this cylinder object in my workspace, which is quite convenient here because now I can take my airspace. Actually, I'll take cylinder mask, I'll right click and say I would like to use this to mask an ROI. And if I say I want to mask this, the airspace, and hit OK, now it has removed everything outside. I can also use the cylinder to create an ROI. Let me show you what I mean. Let's suppose I say I want a new ROI and I want it to be the shape of my small sand pack. We'll have to cover this a little more later. I'm just creating a new ROI. I'm going to call this my cylinder ROI and click OK. I don't want it to be red, so I'm going to make it, I don't know what color I want it to be. I'm going to make it yellow. Now, I have an ROI. It's a completely empty ROI, but I can take my cylinder and my cylinder, my actual cylinder object. See, this is a cylinder and this is an ROI. I can take this cylinder mask and I can say add to ROI, and I'll choose my cylinder ROI. And now I have all of these pixels labeled. We will get into all of this in much more detail in lessons 5 through 10. What I want to show you right now is if I click on some of these ROIs. So I'm going to click on this button, so we're looking at just ROIs. If I click on cylinder ROI, it's telling me the number of pixels that are in this ROI, that is the number of pixels that are labeled yellow. So we can turn on the visibility of any of these. The number of pixels that are labeled yellow is right here. It's 914,000 pixels. Now, I might want to know, of those pixels, what fraction are sand grains? If I come down here and I say compare all of these yellow pixels, that pixel count, with the number of sand grains, and hit refresh, it'll tell me sand grains make up 66.74%. So the volume fraction of sand grains is 66.7%. Inversely, if I asked for the volume fraction of airspace, it's 26.75%. So this is the volume fraction, or the porosity. So, or I said airspace, but I could use pore space. And I think these are, they were computed differently at different times. But the pore space, which is, if you look, here's my pore space. So when I'm down here on cylinder ROI and I compare to pore space, that is the porosity. Okay, now we need to get into multi ROIs, and we're going to take a shortcut to get there. I'm going to go ahead and click all so we see everything over here. I'm going to delete. I don't need my mask anymore. I'm going to click this, and I'm going to shift click all the way through here and hit delete. Okay, now we have this sand grains ROI, and we saw yesterday that I can go to Tools and choose the Pore Network Modeling extension built by Jeff Gostick and coworkers at the University of Waterloo. If I take my Open P&M panel and I go to the Networks tab, I can choose sand grains. So I can say, let's pick sand grains. If I click this button, it's going to generate a network model, but it's also going to generate a multi-ROI. Now, this is just a shortcut for this tutorial on how to get a quick multi-ROI. This is not going to be the standard method for you getting a multi-ROI. What is a multi-ROI? So sand grains labels all of these pixels as orange or not orange. A multi-ROI labels these pixels as grain 1, and these pixels as grain 2, and these pixels as not a grain at all. So we'll talk many times later about how to get multi-ROIs and how to make multi-ROIs, but for today I just want to have a multi-ROI to work with, so we're using this. This is our multi-ROI of sand grains. Okay, now we can see that we're seeing it in 2D, and I do want to come over here. I think my graph is showing. Turn off the graph. Now you can see that when I turn on the visibility of a multi-ROI, it's not automatically turned on in 3D, but I can click this button and now we see the multi-ROI in 3D. I also want to draw your attention, if I click on the multi-ROI and I go down to the property panels, there are some useful buttons here. So I can turn this button up to make these grains brighter or darker. You also have some nice features in that if you want to, let's do this in here. We're going to reduce the brightness. I'm just doing a, well, really I'm just doing the same as this, clicking on this text presenter and dragging down. Now, what I wanted to show you is if I take ROI, I can actually make all of those labeled pixels disappear, or I can make everything that's not a labeled pixel disappear. We will touch more on this in a minute. Now, I have a multi-ROI, and I want to do some analysis. What I'm going to do is I'm going to right-click on the multi-ROI, and I'm going to go to the Connected Components submenu where I can find Analysis. What we have here is the objects analysis panel, and we can see that in this data set there are currently 80 objects or 80 grains. You'll also see if I click over here it says the number is 80. Now I am going to drag the highlight all the way up, and that's going to make a difference in the 3D view since that's what's since this is 3D highlight. At this point, I have an identity or a labeling of each grain. I might like to make measurements, so I can click on this button right here. This is all part of what objects analysis does. And I can say, well, I'm interested in the volume, and I'm interested in the surface area, and I'm interested in the aspect ratio, and we'll also look at, let's say, max location Z, min location Z. We'll see why I care about that in a minute. I click OK. It computes all of those measurements on all 80 grains, and now I have all of those measurements in this table. If I were interested in color coding my data set by volume, for example, I could just click on the volume column, and now my big grains are colored yellow and my small grains are colored blue. If I don't like that color scheme, I could always change to some other, so the big grains are red and the small grains are purple. So I'm color coding by measurement. I could do by surface area or aspect ratio or anything else. I told you I did min Z and max Z. Every one of these objects has a volume measurement, an aspect ratio measurement, a location measurement. If I click min Z, now you can see they're color coded from purple at the bottom to red at the top. So every object has a minimum Z position, and it's getting its color based on the value of its minimum Z position. Right now we're looking at a table of these measurements, but you could also look at a histogram of those measurements. So here is the histogram of aspect ratio, here's the histogram of surface area, and you can see things are changing over here. You could look at aspect ratio and design a filter. So if I said, let's filter all of these, now I can see all the ones that I filtered. Turns out those are the grains that are mostly incomplete. And I think if I select these, I'll be finding mostly grains on the surface. A lot we can do in here. We're not going to get into this right now. I'm just going to remove these filters. So you can look at these measurements either from a histogram perspective or from a table perspective. And you can really dig down into these. Maybe I should get into that for just a minute. I could click this button, create the filter like we just did, and then I could dive into this, and then I could further sort by volume if I wanted. I do need to make my screen a little bit wider. And now we're looking at the volume just on this, which I could make another filter on, but we could look at the volume just on these. So I can partition my data into, high aspect ratio grains and low aspect ratio grains. And then on the low aspect ratio grains, I can continually just subdivide my data. A lot to look at here. We're not going to look in any detail because, we're already 20 minutes into this webinar. I'm going to click here. I'm going to hit remove filter. Now, what I'm going to show you now is I'm going to go back to the table view. Right now, everything is colored by Z position. I'll just tell it to color by volume for now. I have the ability to make selections on this table. So if I sorted by volume and I clicked the top one, so I sorted by volume descending. So right now I have the biggest one selected. If I do a shift click now, I have the biggest 5 selected. Now I have these 2 sliders here, and these are going to modify based on what window I'm in. So if I click this window, it's highlighted. If I click this, I should say view instead of window. So I have a 2D view selected or a 3D view selected. If I have this 3D view selected and I drag complement intensity down, you see that what I'm showing here are my selections. I'm showing the selection of my very large particles. And if I could do this, I could drag down the selection intensity and drag up the complement intensity to see the inverse. So you can make selections. Now, I've made those selections here in the table, but you could also make them here in the graph, here in the view. One thing we have not looked closely at in Dragonfly is that Dragonfly is always in a state. And right now, I cannot drag or rotate this view. If you know your state buttons, if you know Dragonfly, you'll know that on manipulate, there's a track button here, and now I can rotate. But I'm no longer in the objects analysis state, I'm in the track state. This button right here puts me in the objects analysis state. So when I hold down Control and I click the mouse, I can make selections interactively. So now I'm selecting grains, and you can see them appearing here in the list. All of those grains are now part of my selection. I can clear my selection, and I can continue to select grains. Let me see. Yeah, also there is a shortcut key mapped in Dragonfly. So I'm in the object analysis state, which allows me to do this control clicking business, but also I can hold down the T is in Tom, T is in Tango, key on the keyboard. When I hold down the T key and drag, I can rotate, and I'm currently in the track state. As soon as I release the mouse, I'm right back in the objects state, so I can keep clicking. So I can make a selection like this, and then I could say export all of this to an ROI, and now I have those select grains marked as an ROI. I could also export to a CSV. Export to CSV is going to export all of these records. So what is the grain label identifier? What is the volume? What is the surface area? It's just going to export the selected ones. So if you want to export this entire table to CSV, just do a select all and export to CSV. Okay. I think that gives a very brief introduction to everything I wanted to show on the multi-ROI behavior. Keep in mind this behavior of showing the highlight and the complement, it's bound to the currently selected view, which is the 3D view. If I want to do sort of the same analysis in the 2D view, the same coloring, these sliders have one state associated with the 2D views. Click here, another state associated with the 3D view. And for those of you that might be asking, can you click, let's clear our selection, can you click in the 2D? Yes, you can click in the 2D as well. There is also this button, which I think I unchecked accidentally without showing you. If I clear my selection and I now click on a grain, it will take that grain and center it in the 2D views and the 3D view. And so that's what happens when you click a grain unless you uncheck this. Now I can zoom back out. I'm using a middle mouse drag to zoom. Now I can click grains and it's not recentering every time. So that checkbox is quite useful. Sorry, I unchecked that before when you weren't looking. Okay. I do want to mention maybe one or two more things. I'm going to go ahead and close out my objects analysis. And here in the 3D view, I'll double click, and to go full screen, zoom out. I'm going to turn off the visibility here and just show you this is the ROI I created of those selected grains. If I turn it on in 3D, you can see that. Now I want to just show you a feature of an ROI. When you select an ROI, as I described earlier, there is this 3D opacity panel, so I can highlight just those grains that were in that selection. This is a binary ROI. An ROI is just every pixel in the entire data set is either labeled or not labeled. So this loses the individual labeling that you have from a multi-ROI. So this is just an ROI, so I can adjust the highlight, but I can also say I want to hide those grains, so now I can sort of see the inverse. So you can either show those grains and hide everything else, or hide everything else and show those grains. All right, let me have a quick look at my agenda. Yep, I did that, I did that, I did that, I did that, and I did that. I did not show the measurement inspector. Okay, let's look at the measurement inspector. If we come over here and we take our multi-ROI, and what I'm going to do is I am going to go back into objects analysis so I can reset my selection. And what I'm going to do is I'm going to right click on the multi-ROI, and I'm going to come over here to measurement inspector. This is going to pop me into this panel over here. So I've been on the properties tab, but now I have an inspector tab with this control panel. And you can undock this if you want. This control panel allows me to look at the measurements that have been computed on this multi-ROI. So it's a lot like we saw this on meshes in lesson 2. You can also do this on graphs, but we didn't show that in lesson 3. And of course, multi-ROIs have measurements. So we can take a measurement that is computed on these sand grains. So there are measurements that were actually computed beforehand that you didn't see, and then the measurements that we did compute, like aspect ratio. And what I can do is I can say, let's take everything that's outside of my window and turn down its 3D opacity, and turn down, everything that's outside of my window, turn down its highlight. So you can see I'm selecting grains, but you could also say everything that's not selected, we turn down its opacity. So much like we saw with the mesh, we can select on a multi-ROI and get visualization of properties and get differential visualization. So we can adjust the opacity and the highlight intensity of what's in this window. We can also reset the scale bar if you want this scale bar. So right now it's in cubic microns. We're not going to talk about how to change that today, but if you want this to be an even 16 trillion, you could dial that in here. Just type in 16 trillion and put whatever, 27 trillion over here. Okay, that's the measurement inspector. Finally, I will say you can right click on an ROI at any time and do export. So we can do export as ORSObject. Likewise, you can do the same thing on a multi-ROI. Go to export as ORSObject. Okay, 2 things. I know that there's a lot more questions you're going to have, and we will cover those in future webinar topics. This was just to give you a crash course. This whole set of lessons 1 through 5 are to give you a taste of what you can do with images, meshes, graphs, multi-ROIs. Tomorrow with our lesson 5 with the Movie Maker. So this is not meant to be exhaustive. There are a lot more things you can do. The second point is these renderings are not beautiful. I've not done anything today to optimize renderings for making movies or making screenshots. We will talk about that in future lessons. But please go to the feature board and make feature requests for future lessons. With that, I'm going to end the lesson and we're going to go take Q&A. So I've got 24 questions. I'm going to answer as many as I can in the next 5 minutes. The top question in my queue, maybe these don't stay sorted. The top question in my queue is there an undo function in Dragonfly? That's a great question. I wish there could be. Really, the only thing there is an undo for is for image segmentation. It will undo the last action. So if you painted a grain, we'll see this in probably lesson 8 or 9. If you painted a grain or if you did a thresholding, you can undo that last action. It will be very useful, but it's quite limited. It just affects image segmentation. All right, next question. Is it possible to synchronize the pixel resolution on the monitor display with the pixel resolution on the data set? the best idea is to create screenshots with 100% magnification. I'm going to answer the question a little differently. The question disappeared. I'm going to ask the question a little bit differently. When you go to export a screenshot, we haven't covered this at all, but you will see that on the main tab under Scene View Properties, there is Export Screenshot. This is one of the ways for creating a screenshot. And here, this will be a one-to-one mapping of the current view panel. If you wanted this to be the same size as your monitor resolution, the same number of pixels as your monitor resolution, you could enter a larger number here. So if you have a 4K monitor, you could enter whatever, 3076 by 2048. I'm sorry, I don't know the actual numbers, but you could dial in. So I'm going to answer the question that way. If you have a follow-up question, ask me and ask in the forums or something. Next question, if anyone wants zoological micro CT data, you can access University of Michigan's Museum of Zoology page. Outstanding. I'll put a link to that at the top of tomorrow's webinar. It looks like it's a good source for getting some micro CT data. Fantastic. Always love sample data we can work with. Thank you very much for that contribution. Next question, is it possible to measure some custom values by giving the equation? Fantastic question. Yes, you can make, well, yes, no. It's a little tricky to answer. You will see in here, you can go in, when I am in that objects analysis panel, there is a list of measurements. These are the measurements that we ship. There's not a button right here that says volume equivalent spherical diameter equals, and then you type something in. So it's not that simple. However, if you know how to write any Python code, you can come over here and we could give 2 weeks worth of lessons just on extending Dragonfly and Python. You could come over here and say, I want an object analysis statistics. And this is called a generator because this is where you type the name of the code you want, sorry, the name of the measurement you want, and click create, and it creates Python code. And then all you have to do is type in the math for computing the measurement. So there may even be a video tutorial on how to create this. Great question, and we can take follow-up questions on that later. Next question. SSI, serial section imaging, how to correct or reduce the drifting in slices. Aha. Yes, so people do serial section imaging experiments where they may do slices that they then image with an optical microscope or TEM, or they may do fib-sim imaging or 3-view imaging, many sorts of experiments. If you right-click on the data set, you can go to slices registration, and it's right here. This is a whole framework for evaluating the drift between slice 1 and slice 2. There are a number of different functions you can use. This needs to be the topic of its own webinar. So put in a request for that. Next question, could you please explain how we can import 3D fracture surfaces in the Dragonfly and convert them to condensed 3D solid? I don't know the question you're asking. If you mean, can we import a surface and convert to an image? Yes. To a binary image. I can't show it in 30 seconds, so put that as a seminar topic request so I can dedicate some time to it. Can you fix the 3 planes to stay orthogonal? No, you cannot do that. We've had that as a feature request. It's come up once or twice, but it's not something we've done. All that you can do right now is if you happen to tip this plane, so if I happen to tip this plane by changing its yaw or changing its pitch, I think I can right-click and say orthogonalize the other 2 planes, and now they are orthogonal with respect to this one, but as I drag this, these do not get updated, so that feature does not exist. So put that as a feature request or communicate, maybe we can get it in there for Dragonfly 2020.2. The forum is not allowed to register. How do you ask questions there? Excellent, so that's covered at the very beginning of Lesson 1, go to help and go to access Dragonfly forums or request write access to Dragonfly forums. Type in your name and your password here and your email. You will get credentials, and that is how you gain access. Turns out that before we had this, there was constantly bots and spammers registering for accounts and putting spam in the forums. So you can only gain access to an account there. Excellent question. Please go ahead and make your access there. Okay, that just says via morphosource. Not sure what that question means. Next question, we'll take maybe 3 more questions. What is the shortcut key for rotating a sample in 3D or 2D? Okay, so in 3D, let's turn this off. In 3D, if you are in the track state, that's this button, or you just hit the escape key on the keyboard, it'll say track. If I drag the mouse left, it happens like this. If I drag the mouse vertical, it happens like this. So that's the behavior. I don't have to hold down any shortcut keys. If I double click, and then now I double click in one of these views, if you want to rotate the view, then I'm going to change the font right now because I can't see any of this. Let's see if it takes effect right now. If I go to colors and I change my text annotations from black to yellow, I don't know if this will take effect immediately. Oh, good, it took effect immediately. If I wanted to rotate this view in 2D, I'm not sure if that's what you mean, but I could just drag this and it's rotating about the center of the field of view. So it is just changing the view. Okay, 2 more questions. How can I extract or analyze a subvolume? We're not going to talk about clipping today. There is on the feature board, on the topics request board, one topic for clipping and cropping, and that would be where we talk about subvolumes. So put in an upvote for that or add clarification on the comments for that feature request. Last question, Pal asks, for machine learning, will this webinar cover only the deep learning tool or the segmentation trainer? Outstanding question. So we don't have a webinar yet planned for machine learning, and what we will likely do is wait for 2020.1 because the tools you are talking about, segmentation trainer and deep learning tool, they've actually been conjoined in the next version, and there is a way to run a wizard that allows you to start with segmentation trainer methods and then iterate into deep learning methods. So we'll probably cover both of those in one lesson. They'll still be available. You can still do segmentation trainer methods without doing deep learning on the GPU, but we'll probably cover them in the future release because it's one wizard that drives all of it. Okay, if your question wasn't answered today, please put it on the forums or tune in tomorrow for the live webinar and ask your questions at the top of the webinar. As always, thank you everyone for attending. And hey, one more thing, we have 280 people registered for the webinar series. Do me a favor, let's get that up to 300. So tell other people that are interested in image analysis about this webinar series so we can hit that registration benchmark milestone, and also be sure and watch these on YouTube and let other people watch them on YouTube. Let them know about them so they can subscribe and hit like. Thanks everyone. Have a great day and take care and try and stay healthy and best of health to you and your family during these times. Take care. Bye-bye.